Welcome to The Explainer. Today, we're taking a hard look at large language models and their actual performance in the business world. Everyone's talking about the potential, but we're here to get past the hype and dive into the data. We're asking, what can they really do?
So here's how we're going to break it down. First, we'll set the stage with the hype and the hope surrounding these models. Then, we'll introduce a really important study that puts them to the test. After that, we'll walk through 3 key findings from that study, things like research bias and code generation. And finally, we'll wrap it all up with our verdict on what this means for business AI.
All right, let's kick things off with the big promise. It is pretty much impossible to go a day without hearing that AI is going to completely change how we work, right? And large language models are at the absolute center of that conversation.
Exactly, and the promise is both simple and incredibly powerful. Unlike older forms of AI, these models can understand and generate human-like language right out of the box, so you don't need months of specialized training. This means they can, in theory, streamline everything from writing marketing copy to summarizing customer feedback.
And this really shows you just how big the vision is. The idea isn't just to improve one little task. It's about weaving LLMs into the entire life cycle of a project, from analyzing market trends in the planning phase to writing code during implementation, and even analyzing data to make better decisions later on. The potential seems absolutely massive.
But, and it's a big but, with claims this significant, you have to have rigorous testing. You can't just run on hype. And that brings us to the core of our discussion today, a really groundbreaking paper by Ming Chung that gives us a much-needed reality check on all of these capabilities. And that is the billion-dollar question, isn't it? This is exactly what the Chung paper sets out to answer. It's designed to push us past the cool tech demos and anecdotes and get us into the hard, data-driven evidence of what really works and what doesn't. So the study lined up 4 of the heavy hitters in the LLM world, the big, accessible models that companies are actually using. We've got ChatGPT, Claude, Llama 2, and Palm 2. The researchers then put them through a series of experiments designed to mimic very common, everyday business challenges.
All right, let's dig into the first piece of evidence. This one looks at a really fundamental task in the planning phase of any project, doing a literature review, getting up to speed on a new topic. This is something people hope to offload to an AI assistant.
The experiment was really elegant in its simplicity. They gave each model a research topic and asked it to find the 50 most important papers. Now, the clever part is how they checked the answers. They used the actual reference lists from published, peer-reviewed survey papers as the ground truth, so no guesswork involved.
Okay, so what happened? Well, the results were pretty surprising, actually. They revealed a really significant and maybe a little counterintuitive limitation in how these models go about finding information.
The numbers here are just striking. Take a look. Even the best model, Claude, found on average fewer than 2 correct papers out of 50. And it turns out the why is fascinating. The models weren't finding the most relevant papers, they were finding the most popular ones. They favored things they saw a lot in their training data, ignoring niche but critical research.
And that's the real insight here. It's not just about getting facts wrong. It's a systemic popularity bias. The LLMs aren't really researching in the way a human would. They're just matching patterns. And this can create a dangerous echo chamber, skewing your strategy toward what's already well known, not what's necessarily correct or innovative.
Okay, let's move on to the next test. This one moves into the implementation phase and looks at using LLMs to write code for data analysis. This is one of the biggest promised time savers for businesses. So for this experiment, the researchers set up a classic business intelligence scenario. They created 2 simple data tables, one with sales data and another with store traffic information. Then they asked the LLMs to write SQL code to answer some pretty standard business questions based on that data. But here's the crucial part of the test design. They split the questions into 2 types, simple queries that only needed data from one table and complex ones that required the model to join both tables together to calculate something like a conversion rate. That's a much harder logical leap to make. And the results really speak for themselves. You can see this massive cliff they fall off of. For the simple, single-table queries, all the models did reasonably well. But as soon as you ask them to perform a complex join, their accuracy just plummeted. Even ChatGPT, the best performer, struggled significantly.
Right, this really gets to a fundamental gap. An LLM can be great at generating correct syntax. It knows what the code should look like, but it struggles with a deep contextual understanding of why those two tables are related. And without that context, their reliability for any kind of sophisticated analysis is really limited without a human expert double-checking everything.
So for the final test, the study explored one of the most talked about limitations of LLMs, how sensitive they are to the specific way you ask a question. But what's so cool here is that the paper shows how you can actually flip this weakness around and turn it into a strength. Okay, so imagine this scenario. You're running a Q&A section on an e-commerce site. A user might ask, how do I take an item out of my cart? But in your database, the official question is phrased as, can I remove items from my order? The meaning is the same, but the wording is different. The model's job is to figure that out and find the best match.
And this is where the researchers tried something really clever. They asked, what if we use the LLM's own creative ability against the problem? What if we ask the LLM to generate dozens of different ways a user might ask the same question, and then add all those variations to our database to make it richer?
And the results were frankly incredible. This technique, which is called data augmentation, caused a huge jump in accuracy. You can see it here. It went from about 65% to over 85%. The data generated by ChatGPT, in particular, gave the system a massive performance boost. This is such an insightful finding. It shows that, yes, prompt sensitivity is a real challenge, but you can leverage that same generative creativity to build more robust, more flexible systems. You're essentially using the LLM to patch its own weaknesses. It's like turning a bug into a feature. Okay, so we've looked at the hype, we've gone through the tests. What does it all add up to? After this pretty tough reality check, what's the final verdict on using these LLMs in a business setting today?
I think the key takeaway is this. Right now, LLMs are best thought of as incredibly powerful assistants, not as autonomous experts. They are fantastic for accelerating simple, well-defined tasks. But the moment you introduce complexity or deep context or the risk of bias, you absolutely need careful management and human expertise in the loop.
That's the perfect way to put it. They are powerful tools, but they are not magic wands. And what this study really suggests is that the path forward isn't just about building slightly better models. It's about all of us, businesses, individuals, becoming smarter users. It's about understanding both the amazing strengths and the very real limitations of this technology. Thanks for joining us.